Algebra, we are trying CO19 again, which is teaching you how to identify what's called a linear function, which is a subset of the function. So we have these relations, right, which is any collection of ordered pairs, equation, graph, or whatever. We have functions, which are specifically relations where x does not repeat. And now we have what are called linear functions, which can anyone guess what a linear function is just based on the word linear? It gives you a nice hint here. Hugo?
It's like a line.
Yes. Okay. Linear function is a function with slope, which is what makes it a line. Okay. A linear function is a function with slope, which is what makes it a line. Now, you have some history with slope. You talked about it last year in pre-algebra. You learned how to find it. There's a slope formula. You learned to graph with it, right? So you know what slope is. And so what a linear function does, if you look back to PO 18 here, when we introduced functions and function notation, right? This parabola, this U-shaped graph, is a function because x does not repeat. However, is it linear?
No.
No, it's not a line, right? There's no slope there. Whereas g of x, that purple one there, that is a function. It is also a linear function because it does have slope. It is a straight line. So slope and linear functions go hand in hand. The key point here, every linear function, what happened to my, what did I do? Why is it down there now? Weird. Every linear function has slope. Therefore, if you can determine that a relation has slope, you know it is a linear function. Okay. Now, how do we define slope? It's got many definitions. Good thing you're here today then. How would you define slope? Tegan.
Oh, I was just going to say
The formula? Sure, go for it. So that's slope-intercept form. That's what we like to graph linear functions in, but it's slope is m, yes. In slope-intercept form, y equals mx plus b, slope is the m variable. Hugo, how would you define slope?
y2 minus y1 over x2 minus x.
Okay, so the formula for finding slope is y2 minus y1 over x2 minus x1. That's not necessarily what we're doing today, but it is related to slope, and it is going to be a PO coming up, okay, knowing that formula. It was a PO for you last year, actually, also, PO 51, I think. It was on the entrance exam, exactly, okay. Slope must be pretty important then, which it is. But the definition of slope, that's the formula to find it. What is the definition? Yeah. Well, a line will have slope. Yes?
Like a consistent increase or decrease in how the number is going.
Yes, it is a consistent or constant rate of change for y over x. A constant rate of change for y over x is the definition of slope we are going to be using today. Okay, which you can kind of summarize to be right here, the change in y over change in x. If that change in y over change in x is constant, it has slope, therefore it is a linear function. So let's take a look at the first one here. We've got this relation, we've got this table. First of all, is this a function? Let's just answer that first. Because it can't be linear if it's not a function to start with. Is that a function? Yes. X does not repeat itself. Right? 1, 2, 3, 4, there aren't any repeats. So now we look at what's the change in y over change in x. So looking from -3 to -1, what is that change? +2. And it's important to differentiate between +2 and -2 if it's going up 2, increasing, or decreasing. Okay? So change in y is up 2. How about from 1 to -1?
Up 2.
Up 2. How about from 1 to 3?
Up 2.
Up 2. So far, this is looking as if it is linear because that change in y is constant. It's going up 2 every single time. We can't make a final determination, though, until we look at that change in x. What's the change in x from 1 to 2?
1.
+1. From 2 to 3? +1. From 3 to 4? +1. Is this linear?
Yes.
Yes. And you can confirm that because the change in y up 2 over the change in x up 1 is consistent throughout. It has slope. Not only does it have slope, but this is the slope, right? The change in y over a change in x is the slope. How are we doing so far?
Good.
Great. Pick another one in this first row to do together. Aiden.
The last one.
Of course, the last one. Let's look at the last one. Is it a function, first of all?
Yeah.
Yes. Now we have to look at, is it linear? So starting with y, from 2 to 4 is up 2. From 4 to 8 is up 4. I'm getting nervous here. And from 8 to 16 is plus 8. Are we guaranteed at this point that this is non-linear?
Yes.
We're not. Okay. Yes, because slopes are fractions, which means they could simplify to be the same thing. What do I mean by that? Like going from 7 to 11 here is plus 4. Okay? So the relationship of the change in y over change in x of our first set of ordered pairs is 2 over 4. Right? Y is going up 2, x is going up 4. For our second one, where y is going up 4, what would x need to be going up by in order for this still to be linear? 8. Because 2 fourths is equal to 4 eighths. Is it going up by 8? No. Right? It's going up 4 again. And 2 fourths is not equal to 4 fourths. Therefore, we can say it is not linear. So just because y doesn't match up right away, don't discount it yet. You have to compare it to the x. Because slopes being fractions, if the change in y over change in x all simplify to be the same thing, it's still going to be a linear function. Okay? One other of these to do together, because this is so much fun. The other one, there's 2 there.
The third one.
The third one? All right. Third one. Y looks to be going up by 8. And then it goes up by 16. Getting a little bit nervous here, but we can't discount it yet. And then 72 plus 8 gives us 80. So we have plus 8, plus 16, plus 8. Let's look at the x's. From 5 to 10, plus 5. So our initial slope, what we're looking for here, is a change in y of 8 and a change of x of 5. Okay, that's the slope we're trying to find for all these things here. From 10 to 20, plus 10, which gives us a change of y of 16 and a change of x of 10. Are those two things equivalent?
Yes.
Yes, they are. So are we still in business here? Yes, we are. Comparing the last one, 20 to 25 is plus 5. So we have 8 over 5, 16 over 10, 8 over 5. Is it linear?
Yeah.
Yes, it is. And the slope is 8 over 5. That change in y or change in x, positive 8, positive 5. Get the gist of it?
Yeah. You did the bottom.
We'll go to the bottom one. Okay. Questions on what we have up here so far?
No.
Nope. Okay. The bottom section. Another table, 2 more tables for you to look at, and we also have some graphs here. How can you tell if a graph is a linear function? It's a little bit easier. Evan?
If it's straight.
If it's a line, right? If it has slope. If you follow this line from ordered pair to ordered pair, up 1 over 2, up 1 over 2, up 1 over 2, it makes a nice little staircase, right? That means it has slope. Okay, the slope, you're going up 1 over 2 to get from point to point, it is linear. Okay? The next one, it's straight, but is it a line? No. And if you look at slope here, we start by going down 1 over 1, down 1 over 1, but But then we switch to up 1 over 1, up 1 over 1. The slope changes. Okay, it is kind of a weird staircase, yeah. But this is not linear. And you can verify that because, first of all, it's not a line. And second of all, that slope is not constant, not consistent. Okay? Then the two brain busters down at the bottom says make an XY table with at least 4 ordered pairs of a linear function with a slope of -2 sevenths. -2 sevenths. Let's just get this started here. Okay? If we were to make, oh, and you have more at the bottom even. Look at that.
Wait, can you do the table?
What's that?
Can you do one table?
We've already done 3 of those. I think we have enough.
No, but they will subtract and add.
You're looking for that constant change in y or constant change in x. If you need help after done recording, I can help you, but I don't want to go over another one together here. So a slope of -2 sevenths. Okay, here's our function table. Give me a number 1 through 100, Luca.
31.
Great. Give me a number 1 through 100, Kate. 30. Great. Okay. So that's our starting ordered pair here. And we want a change of y or change in x of -2 over 7. First of all, does it matter which number that sign belongs to? It really doesn't. Okay. Typically, it's put with the numerator, which means that the change in y is going to be down 2, and the change in x is going to be +7. You could flip those. You could have change in y being up 2, change in x being down 7. It's still the same. But typically that sign's put with the numerator. So if we're going down 2, what would our next y value be? 28. We've gone down 2, right? That change of down 2. What would our next x value be? 38. We've gone up 7. Right? Then we do it again because we need at least 4 ordered pairs here. So if we continue this, let's throw a curveball. What if I put 20 here, where I went down 8?
Yeah.
What would my next x value be? Ooh. Right? -2 sevenths equals -8 over 28.
No.
Yeah, right? If I multiply my -2 by 4, multiply my 7 by 4 as well, that means over here I've got to go up 28, which puts us at 66. Okay, you don't have to copy me. You can just go down 2, down 2, down 2, down 2, down 2. That's totally fine. Okay? If you want to get a little bit creative, that's how you could do it, right? But as long as that change in y or change in x are equivalent fractions, if they're constant, they're consistent, then you've got yourself a linear function. Okay? Questions, comments, concerns, complaints, comments, congratulations, criticisms on this. Nice way to end the week, short week. CO19 is going to be due on Monday. You've got 15 minutes to work on it now. The spirit of 1,000 Christmases being given to you here. You can work on your math packet if you want, certainly. Okay? This is due on Monday. All right, folks. That's our math.
Don't forget to like and subscribe.